This lesson is about finding exact trig ratios for values other than the ones that we learned in the previous unit. So we learned, just to quickly refresh, we learned the exact trig ratios for the values pi by 6, pi by 4, pi by 3, pi by 2, and any multiple of those, right? We learned how to do that either with the unit circle or with our special triangles. But how could we find the trig ratio for something like cos pi by 12 if it's not one of those values? So let's think about how we could possibly do this. Let's think about, first of all, where cos pi by 12 is, or where pi by 12 is on our circle. And we know it's going to be about half of pi by 6, right? It's going to be somewhere in here, pi by 12. Now, that's okay, but one thing, to make this whole thing a little bit easier, we're actually going to work with degrees because it's a little bit easier to visualize. So I'm just going to actually change all these numbers to degrees. So pi by 2 we know is going to be 90 degrees, pi by 3 is 60 degrees, pi by 4 is 45 degrees, pi by 6 is 30 degrees, and then pi by 12 is just half of pi by 6, so it's 15 degrees. And my question for you is this. If cos pi by 12 is 15 degrees, basically we're finding the cos of 15 degrees, can we represent that 15 degrees as a combination of two other angles we already have? So is there a way to either add or subtract two of these angles to get 15 degrees? Well, it's pretty clear that 60 and 45 are 15 degrees away from each other. So, for example, if we did 60 degrees minus 45 degrees, we should get 15 degrees. So does that mean that cos 15 degrees is just equal to something like cos 60 minus cos 45? Is it that simple? Well, let's look at what's happening here. Remember, cos is just the x part of this line here. If this is our unit circle, we assume all these have a radius of 1, right? The x part of 60 degrees is going to be this piece right here, right? The cos part is there. And then if we look at the x piece of the 45 degrees, it's going to be this value here. If we look at what the x value of the pi by 12, it's going to be, I didn't draw this very well, it should be a little bit longer there if we want to make it all a circle. The x value of that's going to be even longer than those two, right? So it doesn't actually make sense that we're going to subtract those two yellows to get this one over here. So luckily though, so this is wrong, by the way. Let me just cross that out so you don't even think about that, because that doesn't work. We can't just subtract cos values like that. Instead, however, we have identities. So let me zoom out here. If you go to your identities sheet, I'm just going to sort of put it right in front here so we can see it as we work. We have these things called compound angle identities. If I zoom in right like that, we have these things called compound angle identities. And what these tell us is that if we have two angles, for example, that are added up like this, sine x plus y, so two angles inside, we can actually represent it like this, sine x cos y plus cos x sine y, and that's an identity. Same thing goes for cos x plus y, tan x plus y, and then the same thing for all the subtraction ones. So if we have a difference between two angles, and we're taking the sine of that, we can represent it like this. So we're not going to worry about here how to derive these things or where they come from. We're just going to worry about how to use them. So going back to our original question, cos pi by 12. Remember, we said cos pi by 12, or pi by 12, is equivalent of 60 degrees minus 45 degrees. Or, to put it another way, if I was to rewrite this in here, it's the equivalent of saying cosine of what is 60 degrees is pi by 3 minus 45 degrees, which is pi by 4. So do you see, we've just rewritten this in this form. It means exactly the same thing, right? Because pi by 3 minus pi by 4 is just going to be pi by 12. But what we can do now is we know the exact values for pi by 3 and pi by 4, right? We know the cos values and the sine values for pi by 3 by pi by 4. So we can just plug in to our equation our identity, our compound angle identity, specifically this one right here, right, where it's a difference of two angles. We can just plug in those values, pi by 3 and pi by 4, and find what the cos value is. So let's just start by writing out that identity, cos x minus y equals cos x cos y plus sine x sine y. This is where it's important to be very careful. These things are easy to mess up if you're copying down the wrong identity. So now we have that identity there, right? So it's like we've split up cos into, or sorry, we've split up pi by 12 into pi by 3 and pi by 4. And it's like in our equation or in our identity, it's like we've made x, pi by 3x and pi by 4y, right? And just subtracted those two things. So basically everywhere we see an x and a y here, we can just replace with pi by 3 and pi by 4. And clearly the nice thing here is that this only will have pi by 3s and pi by 4s in it. It won't have any pi by 12s, which is the whole point of doing this, right? We can find the exact value for cos pi by 3 and pi by 4. So anyways, let's plug in our values. So it's going to be cos pi by 3, because that's what our x is, cos y, which is pi by 4, plus sine pi by 3, sine pi by 4. So now we just have to think about, you can use whatever method you want, unit circles, special triangles, to come up with these values. So cos pi by 3 is just 1/2. Cos pi by 4 is 1 over root 2, plus sine pi by 3 is going to be root 3 over 2, and sine pi by 4 is 1 over root 2. And we can simplify. 1 over 2 root 2 plus root 3 over 2 root 2. And then further simplify, we already have a common denominator, so 1 plus root 3 over 2 root 2. There we go. That's the exact value for cos pi by 12. You see, we were able to break it up. Once again, we were just able to break it up into two values that we know the exact value for, plug it into this identity, and come up with that answer. Now what I want you to do is try B yourself. Pause the video, try it, unpause when you're ready. So looking here, the answer actually comes out to the exact same thing as this previous question. It turns out because we can represent sine 5 pi by 12, we can represent 5 pi by 12 as pi by 4 plus pi by 3. Again, if you have trouble coming up with that, convert them to degrees, and you'll just see it's 45 degrees plus 35 degrees, or sorry, plus 30 degrees gives us 75 degrees, which is what 5 pi by 12 is, 75 degrees. So here, we used this one up here on our equation sheet, sine x plus y. And using that identity, we come up to the same value. I'll leave you to think about why it comes up to the same value as cos of 15 degrees, why cos of 75 degrees, or sorry, sine of 75 degrees is the same. There's a good reason. If you just look at the unit circle, you should be able to figure it out. So for example 2, we're asked to find sine x minus y if cos x equals 4/5 and sine y equals negative 24/25. So we're given the exact values for the cos x and the sine y, and we have to sort of figure out what sine x minus y would be. Now, there's an obvious way to do this, which is to find out what the angles x and y are, and then sort of work backward from there. But using this identity, we actually don't even need to know what the angles x and y are. So let's start by writing down our identity for sine x minus y. So I'm just going to copy it from our formula sheet. Sine x minus y is just equal to sine x cos y minus cos x sine y. So that's okay. We happen to know already what cos x is, right? That's given in the question. And we know what sine y is. So those two things are given in the question. We need to, though, find sine x and cos y to make this thing work. How can we do that? Let's draw a sketch. So cos x equals 4/5. It actually tells us in the question that x is between 0 and pi by 2. So that tells us that x is in the first quadrant, right? So we know this little angle in here is going to be our value of x, right? So going back to the question, it says cos x is 4/5. So just from our little sketch, we know 4 and 5. Well, 5 is going to be our hypotenuse, and 4 is going to be our adjacent, right? So if we draw a right angle triangle here, this is going to be 4, this is going to be 5. And you can solve for that third side using whatever method you want, or you can just realize it's a 3, 4, 5 triangle. So this should actually be 3. Now, can we find sine of that angle, sine of x? Yep, it's just going to be opposite over hypotenuse, right? So sine x is going to be opposite, which is 3 over 5. And we can check, of course, is sine going to be positive in the first quadrant? Yeah, both of them are positive in the first quadrant. So that solves our sine x problem. So now we can do the same thing for cos y. If we draw a quick sketch of angle y, we can do the same thing. So it tells us in the question, y is between pi and 3/2 pi, which is the third quadrant, right? So y is going to be somewhere down here. And it also tells us in the question that sine y is negative 24 by 25. So that means 25 is our hypotenuse, and because it's sine, opposite will be negative 24, right? That means our adjacent side, again, we can use the Pythagorean theorem or whatever we want to find that, it's going to come out to 7. And if we think about this as a coordinate down here, this value of 7 is going to be a negative value, right? We can also think about it, is cosine going to be positive or negative in this quadrant? And the answer is, in this quadrant, in the third quadrant, cosine is going to be negative. So cosine of y is equal to adjacent, which is negative 7 over 25. There we go. We know our last two values. So now we can evaluate our expression, right? So plug them in, simplify, and I'll meet you at the answer. So there we go. The answer comes out to 3/5. So here's another problem. We just need to simplify this expression. This expression has two parts, right? A cos with two things inside, think two angles being added essentially, and a sine with two angles being added. So when stuck, go back to your identity sheet, right? This is those same compound angle identities that we're going to need to use here as we used in the previous one, right? So plugging in these values of x and pi by 3 into, which one do we have to use? Cos x plus y, right? So cos x plus y, we'll have to use, oops, not that one. We'll have to use this one, right, for that first term. And then we're going to have to use for the second one, sine x plus y. We're going to have to use this one, right? So try this example, expand, simplify, do whatever you can, and see how simple you can get it at the end. Pause the video here and unpause when you're ready. So I've plugged in all the values here, right? I used the identity for cos x plus y and came out with this. I used the identity for sine x plus y and I came out with this. I put brackets around these because we have to remember that this negative applies to both terms. So then simplifying, cos pi by 3 is just 1/2, so I wrote that out in front, 1/2 cos x. And then sine pi by 3 is just negative root 3 over 2, or sorry, positive root 3 over 2. And then continuing on, I did that for basically each term. Now, you can see we have a positive 1/2 cos x over here and a negative 1/2 cos x over here, so those are going to cancel each other out. And then we have these two terms in the middle, negative root 3 over 2 sine x, which are just going to add together, right, because there's two of them. So it's going to be negative 2 root 3 over 2 sine x, which is, of course, going to simplify to negative root 3 sine x. There we go. That's it. So something relatively complicated at the beginning actually comes out to something very simple at the end, and that's because we were using all the exact trig ratios that we know how to use. So now what we have so far is a way to add two angles together and find out how the sine, cosine, or tangent ratios will react when we add those two angles together. And we do that basically by these compound angle formulas that we just did. The next thing is, what if we multiplied an angle? How would the cosine, sine, or tangent ratios react if we did that? And specifically, the one we're going to focus on is called a double angle identity. So say we had an angle of 10 degrees. If we multiply that angle by 2, how would the sine, cosine, and tangent ratios be affected? And that's what these ratios do. So you can plug in an angle x, right? And what it's going to do is going to tell you what the sine ratio is for 2x. So this might be useful in a case like this where we have cos pi by 8. Cos pi by 8 is not one of our regular angles that we would find on our unit circle or our special triangles, but we do know what cos pi by 4 is. So if cos pi by 4, or pi by 4 is the angle, half of that angle would be pi by 8, right? So we should be able to, if we can use that formula, we should be able to figure out what the exact ratio is for cos pi by 8. So you'll notice for cos, there's actually more than one identity we can use. And in this case, I'm going to use this one, that cos 2x is equal to 2 cos squared x minus 1, just because cos is already in there and it's not more complicated. It doesn't have sine as well. So it's pretty straightforward to use. So this is the thing. 2x, our double angle, in this case, if we wanted pi by 8 to be our x, 2x is clearly going to be our pi by 4. Right? So in order to solve this, basically we're going to treat pi by 8 as our x, so that's what we're going to plug in here, and the pi by 4 is going to be here. We, in this case, know what that pi by 4, the cos of pi by 4 is, so we can use that to solve for x. So let's see what this looks like. Cos 2x is going to be cos of pi by 4, and that's going to equal 2 cos squared of x is pi by 8 minus 1. We know what cos pi by 4 is. Cos pi by 4 is just going to be 1 over root 2. And that's going to equal 2 cos squared pi by 8 minus 1. So again, what we're trying to do here is we're trying to find cos pi by 8. So basically we've got to isolate cos pi by 8. So let's do that one step at a time. I'm going to start moving that 1 over. So we get 1 over root 2 plus 1 equals 2 cos squared pi by 8. Then I'm going to divide both sides by 2 to get rid of that. So I'm going to end up being, if I divide both these terms, I'm going to end up with 1 over 2 root 2 plus 1/2 is equal to cos squared pi by 8. And remember, what cos squared pi by 8 means, that just means cos pi by 8 squared, right? So in order to get rid of that squared, I can just take the square root of both sides. What that gives me is cos pi by 8 is just equal to the square root of 1 over 2 root 2 plus 1/2 all under that square root. We can obviously simplify this a little bit more. If I wanted to put it under 1 fraction, I can get something like this and then rationalize the denominator and stuff like that. I'm gonna stick with putting it over 1 fraction. So 1 plus root 2 over 2 root 2. And there we go. That's what cos pi by 8 is. So this is a handy formula whenever we're trying to find the cosine, sine, or tangent of an angle's double. So if you double the angle, what does that cosine, sine, or tangent become? Okay, here we go. Last question. Sine x is equal to 4/5. How can we find cos 2x and sine 2x? One way we could do this is just use inverse sine, find the angle that corresponds to 4/5, and then basically double that angle, find the cosine of that, find the sine of that. That's one way to do it. But because we have our double angle identities, we can actually skip the step of finding the angle. We don't even need to know what the angle is at all, because we know what we need to do to that 4/5 in order to find what that is. We actually have 3 double angle formulas we can choose from for cos 2x. But considering we're given sine of x, the easiest one to use would be that one that's 1 minus 2 sine squared of x, right? Because we already know what sine of x is. So here, putting this in, we know this is just going to be 1 minus 2. Remember what sine squared of x actually means. It just means sine x squared. So sine, we know sine of x is, well, actually, let's just leave it as sine x squared like that. But we know that sine x is equal to 4/5, right? So this is just 2 times 4/5 squared. And if we do that algebra, what we end up with is that cos 2x is equal to negative 3/5. So without even finding the angle x, we can find what cos 2x is of that angle. Okay, no problem. Let's go on to the second one. Try yourself, by the way, to see if you can figure it out. Okay, so how we're going to tackle this one? Sine 2x, we only have one identity for that, and that's that sine 2x is equal to 2 sine x cos x. Now, there's a problem with this, because we know what sine x is, right? Sine x is just 4/5, but we don't know what cos x is. So what do you think we're going to do? Draw a sketch. The question tells us this angle is in quadrant 2, right? And we know that sine x is 4/5. Remember, sine is opposite over hypotenuse, so it's telling us basically the opposite length in that triangle is 4, and the hypotenuse is 5. Cosine, for cosine, we need to know what the adjacent side is. And if you use Pythagorean theorem, that's going to be a 3. It's just our 3, 4, 5 triangle. So that tells us that cosine of this angle x, whatever it is, we don't need to know the value of it, is just going to equal 3/5. Cool, because now we have everything we need to plug it in here. So 2 sine x cos x is going to be 2 sine x is 4/5, we're given that in the question, and cos x is 3/5, we're given that in the question. If we simplify this, oh, sorry, I made a mistake. Did you catch it? Almost missed that. Cosine in the second quadrant, is that going to be positive or negative? It's going to be negative. That 3 is going to be a negative, right? Because it's like in the negative x direction. So this is actually going to be negative 3/5. So when we solve this, it's going to be negative 24/25. And that's it. That's our sine 2x. That's what the value equals.